Here we have been asked to find the order of the yield of the following organic compounds when 1-methyl 1,3-cyclohexadiene is going to react with HCl at 50 degrees centigrade. Now this is a very important question, and there is something very specific mentioned here, that we have a temperature of 50 degrees centigrade. Now for these type of chemical reactions, 50 degrees centigrade is taken as a high temperature. What you also must have observed is that we have been given a specific organic compound, 1-methyl 1,3-cyclohexadiene. So the general approach is to first make the molecular structure of this chemical compound. Now we start with a cyclohexane, and at the first carbon atom we have a methyl at the first position, and at 1 and 3 we have two double bonds. I number the carbon atoms so you can understand how we got this structure. 1, 2, 3, 4. So this is the structure of 1-methyl 1,3-cyclohexadiene. Now let us try to understand how the reaction happens. So here I have my reactant, my base reactant, which is the given organic compound. Now I have HCl at a temperature of 50 degrees. So my hydrogen ion, or H plus ion, basically is going to be added to this compound to form a carbocation. And now how do we observe as to which is the exact molecule or the exact ion which is formed here? The rule is simple. The charge on the ion, which is going to be the positive charge here, it has to be in a resonance with a double bond, and also the positive charge has to be stable. So here what we are able to see is that here we have a resonance, here also we have a resonance, but here the carbocation is a 2-degree carbocation, and here in the second case the carbocation is a 3-degree carbocation. What you also have to understand is that in carbocation 1 and carbocation 2, these two are the hybrids of the same carbocation. These two are going to be a resonance hybrids of each other, and now since the carbocation has been formed, the Cl minus, which is going to be a nucleophile, has to attack the positive charge, leading to formation of the organic compound. And also what we have to understand, that the carbocation 1 here is going to be having a lower degree of stability, and carbocation 2 is going to have a higher degree of stability, as the 2-degree carbocation always will be less stable as compared to a 3-degree carbocation. Now this is a Markovnikov addition, and at a higher temperature I will obtain the TCP, or a thermodynamically controlled product, and at a lower reaction temperature I will obtain a KCP, which is a kinetically controlled product. And here the reaction temperature is high, as in this is a reaction in which a TCP will be formed, and TCP is always the product which involves the intermediate having a lower stability. Thus here my thermodynamically controlled product is going to be formed as a major product, and the product involving the higher stability intermediate is going to be a KCP, a kinetically controlled product, which at a higher reaction temperature is going to be only a minor product. Now, when I look at the options that have been given to me, what I understand is that my major product is the TCP, which here is shown as organic compound 2. The KCP which I have is shown as organic compound 1. My TCP is the major product. Hence, upon analysis of the given options, we can very well conclude that the appropriate answer is option B. 2 is having higher yield than 1 is having higher yield than the third organic compound. In fact, the third organic compound even won't be formed here.